All right, so we have another problem here. A 15-foot ladder is resting against a vertical wall. If the bottom of the ladder... Okay, wait a minute. Maybe I should start drawing while I'm looking at this. Okay, so let's see. 15-foot ladder is resting against a vertical wall. Okay, so let's draw a wall and a floor. Let me try that again. Wall, floor. And then a 15-foot ladder is resting against the wall. Okay, that means the length of this ladder is 15 feet. Okay. The bottom of the ladder is sliding away from the wall. The bottom of the ladder slides away from the wall at 1/2 foot per second. So the bottom is here. It's sliding away from the wall. So this rate is 1/2 foot per second. Okay. I'm going to think of this as like the x-axis, but I know it's going to the left. And then I'm going to think of this up here, the wall's height, as the y-axis. Okay. So this information that I have so far, that the ladder is sliding away from the wall at 1/2 foot per second, that's a rate of change of this x that I defined. So I'm going to say that this rate of change, this movement, is dx dt, and it's equal to, according to the problem, 1/2 foot per second. All right, so I'm going to keep reading the problem, see if I can add anything to my picture or get a sense of what is being asked for, or see if there's anything else I need to identify. All right, the question is, how fast is the top of the ladder sliding down the wall? Let's stop there for a moment. So we said that this vertical direction is being measured using our variable y. So the top of the ladder, how high the top of the ladder is, we could just call that y. And it's saying how fast is the top of the ladder sliding down the wall. Okay, so we're asking for how fast something is going down. Let's think about that for a moment. If we're thinking about how fast something is sliding down, that's going to be the dy dt. It's important to notice that dy dt will be negative. Okay? Because as we said in the previous video, decrease means negative derivative. All right. So again, how fast is the top of the ladder sliding down the wall when the top of the ladder is 5 feet from the bottom of the wall? Okay, so when the top of the ladder is 5 feet from the bottom of the wall. Okay, so what that tells us is we're answering this question. So we're answering this question in the situation when y equals 5 feet. Okay, so let's see. What do we have? We have, a right triangle, and we're saying that the bottom, or the horizontal leg, is called x, the vertical leg is called y, and we're saying that the hypotenuse of this right triangle is 15. Okay, again, it's a right triangle because the wall meets the floor at a right angle. A good equation that we could use then is x squared plus y squared equals 15 squared. That's the Pythagorean theorem, also known as the Gödel theorem, if you watch Mind Your Decisions on YouTube. So once I have an appropriate equation, I then need to take the derivative of it with respect to t on both sides. So I'm going to do that. I'm going to get, wait, you should try it first. Pause the video, finish this part for practice, and then come back. All right. I'm assuming you tried it. So what we would get is 2x dx dt plus 2y dy dt equals 0, since 15 squared is just a constant. All right, let's see, what do we know? We know dx dt. We know that y is going to be 5 feet in this particular situation that they're asking about. We want to know dy dt because they're saying how fast is the top of the ladder sliding down the wall. So we want to know dy dt. We know that y is 5 in this particular snapshot of time. We know dx dt because dx dt is 1/2 foot per second. We can plug that in there. We don't seem to know x, but we have this relationship between x and y and 15. All right, so let's use that. In the case when y equals 5, we have the following right triangle. We have x, we have 5, and we have 15. That means we can use the Pythagorean theorem again to solve for x. We have x squared plus 5 squared equals 15 squared. Again, this is just one snapshot of time, one instance. We're just answering the question when y is equal to 5 feet, because y is changing. That's what this derivative is indicating. And if you think about a ladder sliding down the wall, it makes sense that y is changing, as is x. Anyway, let's check back at our equation here and work on solving for x so we can plug in what we know into the main equation that will answer the question they're asking. All right, so x squared plus 25 equals 225. Solving for x, we get x squared is 200, so x is square root of 200, and we shouldn't be afraid to simplify radicals. It's 10 root 2, and again, that's in feet. All right, so I'm going to plug all of this in to my equation, and then the thing we're looking for, I'm going to solve for it. Let's give ourselves a little more room. Okay. All right, so we have 2 times 10 root 2 times dx dt, which is 1/2, plus 2 times y, which we said was 5 feet, times dy dt, which is the thing we don't know, and that all equals 0. I'm gonna do a little bit of simplifying here. I have 10 root 2 plus 10 dy dt equals 0. So I'm gonna just proceed to do the algebra to solve for dy dt. At this point, you should hopefully be predicting that dy dt is negative, which it should be based on the observation we made earlier. Okay. So finishing the solving of this equation, if we divide by 10 on both sides, we get that dy dt is equal to negative root 2. Again, we need to remember the units. What was this? It was feet and seconds. There it is over there. So dy dt is negative root 2 feet per second. Again, to write this as a sentence to answer the question, how fast is the top of the ladder sliding down the wall when the top of the ladder is 5 feet from the bottom of the wall? So the main phrase we need is how fast is the top of the ladder sliding down the wall? So let's use that to try to write a final answer in a complete sentence. The ladder is sliding down the wall, or I should say the top of the ladder is sliding down the wall at a rate of root 2 feet per second. Okay, again, you might be asking, why didn't I put the minus sign? There was a minus sign here, I didn't put it here. But remember, we said we're sliding down the wall. That's a decrease. Okay, so this negative here is being reflected in the word down, which means when I write the number in my sentence, I don't need the minus sign. I shouldn't put the minus sign.